All right. Okay. So welcome, scholars. We're going to start off here. Do my view as a single page. Let me see as far. Oh, I must do this as well. This helps. Let me just. Okay. I'll give it a little bit of time to load. Let me see. Can you guys see my screen at all? It should be a blank white screen. Okay, I'm going to assume that it's working until you guys say something. Let me see. Okay. So we're in the home stretch, right? So this week, we're going to be working on the last of the new material, which is going to be section 6.4, solving systems of equations in two variables. We'll get through as much of the notes together as we can. As usual, I have pre-recorded lectures for this section. So that's what we're going to work on this week. Next week on Monday, so I'm under the impression that we're only going to meet on Monday and that Wednesday is a holiday. That's usually how we do it. So then, we'll start to review for the final exam, right? So I think after this week, we'll meet 3 more times. So we'll take each day to go through an exam since we have 3 exams. So next Monday we'll review exam 1, and then the following Monday we'll do exam 2. And then at Wednesday, November 30th, it should be the last day of class, right? We'll work on exam 3. As far as your final, it should become available that Sunday, which is December 4th. It should become available that Sunday, December 4th at 11:11 a.m., but it's going to be due that Friday, December 9th at 11:59 p.m. So that's the hard deadline for all assignments. Okay, so there's no you can't turn in the final late, because once we hit that hard deadline, that's it. Because then we have to crunch grades. We have to calculate final grades. So now is a good time to get all of your other documents on Pearson in order. Like if you're trying to improve your overall grade, I would recommend you prioritize your old exams, as they count for 80% of your overall grade. You can even work on them now, right? Like while we're just here together. I'm going to kind of actually don't know now, because you could, if you had a question, we could talk about it. But I'm going to take some time to go through this last section. But yeah, I would encourage you to prioritize your old exams first, as they're 80% of your overall grade, and you want to prioritize your homework last, because that's going to be a whole bunch of work for little to no points. Right? You're not going to see a big shift in your grade by doing the homework. But the exams, getting those in order, that's where you're going to get the most bang for your bucks. I think that's it. And then the goal is, when you finish your final exam, that's it. So when you turn in your final, you shouldn't have anything lingering, okay? As usual, if you have questions, feel free to unmute yourself, and we're going to take some time to get through as many of these questions as we can. Now, I feel like you can't see my screen. So let me see, what can I do to get that to work? I think it's this guy. I usually have to reboot. I think I'm done with that as well. And then let's go here and let's just reboot this as well. Okay, you guys look good there. Share my screen. Let's turn this off and let's start the broadcast. Okay. There we go. Okay, it looks like it's coming through. All right. Yeah, so I've learned, like, basically I'm watching my stream as I stream, and then that way, that's how I was like, okay, maybe you guys can't see my screen, and so that way I can get a sense of what you guys can see. Anywho, okay. So let's see, what do we have here? So again, this is the last in the new material. It's chapter 6, which are further topics in algebra. And we're going to be working on section 6.4, systems of equations in two variables. A few objectives here. We like to verify a solution to a system of equations. We like to solve a system of equations by the graphical method, solve a system of equations by the substitution method, solve a system of equations by the elimination method, and then solve applied problems by solving system of equations, okay? Okay. So then we have a few definitions here. It says a set of equations with common variables is called a system of equations. If each equation is linear, then it's a system of linear equations or a linear system of equations. If at least one equation is nonlinear, then the system is called a nonlinear system of equations. Here's a system of two linear equations and two variables, right? So when we're solving a system of equations, every time we have an unknown, we need an equation. In this example, we have two unknowns, x and y. So we have two equations, so we're ready to solve. A system of equations is sometimes referred to as a set of, simultaneous equations. A solution of a system of equations in two variables x and y is an ordered pair of numbers a and b such that when x is replaced by a and y is replaced by b, all resulting equations in the system are true. The solution set of a system of equations is a set of all solutions of the system, right? So, the solution to the system is going to be the ordered pair x comma y that when you plug it into each equation, it makes all the equations true. Okay. So here we're asked to verify that the order pair 3 comma 1 is a solution to the system of linear equations. So when x is 3 and y is 1, it should make each one of them true. So then if we do 2 times 3 minus 1, that's going to be 6 minus 1, which is 5. Okay, that one checks out. And then 3 plus 2 times 1. That's going to be 3 plus 2, which is 5. And that checks out as well. Okay. So then that confirms, or we verify that the ordered pair 3 comma 1 is a solution to this system. And here's a typed version of what we just did. As always, if anything is not clear, feel free to unmute yourself to get my attention. That's my recommendation. You can also type in the chat. It's just a slower response time when it's in the chat, right? Because I don't get notifications for those until I go to look for them. Okay. Use the graphical method to solve the system of equations. Okay. So they're basically asking us, does anybody have a favorite color? Anyone have a favorite color? Purple. Anybody else got another favorite color? Okay, let's go purple and orange. So we'll do this one in purple. So with equation 1, let's solve for y. If we solve for y in equation 1, add and subtract, we get y equals 2x minus 4. And I think we chose orange. If we solve for y in the second equation, let me see, we're going to get y equals, subtract, negative 2/3 x plus 4. Okay, so we're going to plot these two. and get my menu to pop back up. There it is. This one. So we got some graph paper. Okay. Let's start with the origin about here. Okay. Y-intercept, so plus or minus 4. Let's see. So we can go like 1, 2, 3, 4, 5, 6. That should be enough. 1, 2, 3, 4, 5 should be good. 1, 2, 3, 4. That's good actually. And a couple this way. So this will be a positive x direction going this way. Oh, let's try it again. Positive x is going this way. Okay. Positive y is going this way. Okay, here's our origin. 1, 2, 3, 4, 5, 6. 3, 4, 5. Okay, that's fine. Okay. So now with the purple one, it says the y-intercept is -4, so I'm going to put a point at -4, and then the slope is a +2. So we go up 2 over 1, up 2 over 1, 2 over 1, right? So we get a graph like this. Okay. And then with the orange, the y-intercept is 4. The slope is a -2 by 3, so down 2 and right 3. Down 2, right 3 is here. Here. Okay. So then notice that they cross at the point 3, 2. So our claim is that the solution to this set is the ordered pair 3, 2. So we saw in a graphical sense how to solve a system. Basically, wherever the graphs intersect is going to be the solution to the system. Okay, and then you can just do a quick check, right? If you said 2 times 3 minus 2, 6 minus 2 is 4. That one checks out. And then 2 times 3 plus 3 times 2 is indeed 12. That checks out as well. Okay. All right, let me check on you guys in Zoom. All right, let's keep going. Okay, I think so here's a type version of what we just did or what we just experienced, all right? Okay. So then we have solutions of systems of equations. The solution set of a system of 2 linear equations in 2 variables can be classified in one of the following ways. So what we saw so far is where we have one solution, the system is consistent and the equations are said to be independent, right? So this is an example. We said that this system is consistent and the equations are independent. But then in this example, we have no solutions. When we have 2 parallel lines, the lines are parallel, the system is inconsistent. Okay, so we would say that this is inconsistent. And then when you have one line on top of the other, we have infinitely many solutions. The lines coincide. The system is consistent and the equations are said to be dependent. Usually, algebraically, you'll see it appear as one equation is a multiple of the other. Okay. All right. So solve this system. Okay. So there are at least two more techniques that we'd like to introduce, and I'm going to go ahead and introduce. Oh, that is what. Okay, I didn't even see that before. Okay. So here we're going to introduce the substitution method, where we're going to solve for one of the variables in one equation, and then whatever answer we get there, we're going to plug it into the other equation. All right. So it looks like it's easier to solve for y in equation 2. So if we solve for y in equation 2, we're going to get y equals 2x plus 9. So then we're going to take this and plug it into equation 1. That's going to give us 2x minus 5 times y equals 3, but we just said that y is 2x plus 9. Okay, so now at this point we have one equation, one unknown we can solve. Okay, so then we can distribute this negative 5. We get 2x minus 10x minus 45 equals 3. Okay, 2 minus 10 is negative 8. Okay, so we'll have negative 8x equals 48. I think x equals negative 6. Okay. So then if x is negative 6, we can take this and plug it back into the equation for y. So then y is going to be equal to, that's going to be what, negative 12, so it's going to be negative 3. Let's be consistent with our colors. Okay. So then our claim is that the solution to the system is going to be the ordered pair negative 6, negative 3. Okay. All right, and then so with something like this, it's a good idea to check by plugging in. So we would have negative 12 plus 15 is indeed 3. Negative 3 plus 12 is indeed 9. All right. Okay. Let me check on you guys in Zoom. Okay. And here's a type version of what we just experienced, and I think they got the same result that we got. Okay. So let's try the same technique that we just used, right? The substitution. So say we were to solve for y in equation 1. Equation 1 looks like it's easier to solve for y there. So then from equation 1, we get that y equals negative, that's not a negative, negative x plus 3, right? So then if we take this and plug it in the equation 2, let's see what happens. So then we get 2x plus 2 times y equals 9, but we just said y is negative x plus 3. So then we can distribute. We get 2x minus 2x plus 6 equals 9. Okay, notice that this cancels this. If you subtract 6 on both sides, you'll get 0 equals 3. This is false. All right, this is false. So notice that our x is canceled and we finish with the false statement. So then that tells us that this system is inconsistent. These lines are parallel, where they're going to have the same slope but different y-intercepts. Okay. So we would say like no solution or inconsistent. I'm just going to say no solution. Okay. 222. Let's see if I can get this. Okay. Yeah, monitoring my own live actually helps. I can see what's working, when it's not. This one. All right. Okay. So then we have a type version of what we just experienced. So they did the same thing. They solved for y first. They plugged it in. Then they finished with a false statement. The system is inconsistent. The lines are parallel and do not intersect, and the solution has no solution. Okay. Okay. We can still use substitution here. So let's go ahead and do that here as well. I'm going to solve for y in equation 2. That one just looks like it's the easiest to solve for y in. So if I add y and add 6, so from equation 2, we'll get y equals basically 6 minus 2x, right? Add and add 6 minus 2x. So then I'm going to take this and plug it into equation 1. So then we're going to have 4x plus 2 times y equals 12. But y is 6 minus 2x. Then we can distribute. Okay. We get 4x, 6 times 2 is 12. Minus 4x equals 12. Notice that a number plus its opposite adds to 0. If you subtract 12 from both sides, you finish with 0 equals 0. This is true. This is true, right? So in this case, when all the variables cancel like that and we finish with the true statement, that means that the system is consistent and the equations are dependent. One should be a multiple of the other. Thank you. Stop. One should be a multiple of the other, right? So notice if we said equation 2 times -2, then we're going to get this guy here. We're going to get equation 1. So when one equation is a multiple of the other, then, you know, the system is consistent and the equations are dependent. We have infinitely many solutions. And the solutions are going to take on the form x, comma, 6 minus 2x, all right? So no matter what x we choose, can I? Nope. Nope. Right, and basically that y is the y that we solved earlier, right? No matter what x we choose, the y's are going to take on that form. Okay, and you can choose your favorite x value. For instance, let's say we chose 3. And then when x is 3, y is what, 0? So then 3 comma 0 should work in all the equations. All right. So 4 times 3 is 12. 2 times 3 is -6. And these go to 0 because y was 0 when x was 3. Okay, hopefully that makes sense. When you have infinitely many solutions, we usually write it like this. We say the equations are dependent. No matter what x you choose, the corresponding y's are going to take on this form. Okay. What's the time? Okay. And here's a type version of what we just experienced. So I think they solved for y as well. They did exactly the same steps we did. Okay. It says the solutions are of the form x comma 6 minus 2x, and the solution set is this. The solution set consists of all ordered pairs x comma y lying on the line with this equation. The system has infinitely many solutions, right? So, okay, that's just reiterating what we already had. Okay. We're asked to solve this system. We have 2x plus 3y equals 21. So here's an example of the elimination method. Okay. So with the elimination method, let's see, do I need more space? Probably should give myself some space. Let me not try to jam this in there. Oh, talk on it. I forgot it causes this thing to freeze. It's so temperamental, man. You can't like do anything without it like throwing attention. It's okay. Now, where do we leave off? Did I lose all my work? I hope not. Let me see, we left off here. Substitution, yeah. Okay, that's the one we just did. We did that one. We did this one. This is where we are. Want to add a page. You still not gonna let me add a page? Are you serious? Come on. Sorry, guys. Yeah, I don't understand. Okay, let me close this out. Give me a moment. It's totally throwing a tantrum. I'll be right back. Ugh. That's fine. Finally. Okay. So let's do view, single page, or seamless, I guess. All right, let's try this again. Zoom. Share the screen. Start the broadcast. Optimize for video. Okay, so we are back. Trying to wait to, at least if I can see it in the live. Come on. Okay, all right, I'm gonna go with that. Okay, so we're working with, we have this 2x plus 3y equals 21. We also have 3x minus 4y equals 23. And we're gonna use the elimination method. So we're gonna start here. Okay. It looks like it's working. Okay. So the goal or the objective when we're doing the elimination method, we want to pick a variable that we want to eliminate. And then we're going to multiply one or the other or both equations by a real number. The goal is to multiply each row so that one of the variables has the exact same coefficients with opposite signs. Now, with my students earlier, I think we chose the x to eliminate. I think with you guys, I'm going to choose the y to eliminate, right? So if I wanted to eliminate y, I think the least common multiple between 3 and 4 is going to be 12. So we're going to multiply equation 1 by 4, equation 2 by 3, and we're going to get those to be the same number with opposite signs, the same coefficient with opposite signs. So we're going to multiply this row times 3. We're going to multiply this row times, sorry, not by 3. We're going to multiply this row times 4, right? Because we want to get it to 12. We're going to multiply this row times 3. Okay. Now, when we do this, we're going to get 8x. We're going to get 12y. And we're going to get 84. Then we're going to get 9x minus 12y. What is that? Is that 69? When you add these two together, notice a number plus its opposite adds to 0. So then we have 17x, 140, 153. Hey Siri, what's 153 divided by 17?
153 divided by 17 is 9.
9, I was way off. Okay. So then we take this result and we can plug it into either equation. I feel like equation 1 might be a little bit easier to work with. I'm going to kind of work on the side here. So when x is 9, then we're going to have 2 times 9 plus 3y equals 21. So that's going to be 18 plus 3y equals 21. We're going to get 3y equals 3, y equals 1. So then our claim for the solution to the system is going to be 9, 1. Okay. Again, if anything is not clear, feel free to unmute yourself. You have to ask questions. If you're not asking questions, then you're doing yourself a disservice, right? We're here because we don't know, right? If we knew, we wouldn't be in this class. We wouldn't be here in this space and time, right? And it's like, I don't know, everybody's afraid to be wrong, but that's, how do you expect to be great if you're never wrong, right? If you were perfect, why are you even here? You wouldn't even be on this planet if you were perfect, right? You know what I mean? So this is a planet of trial and error. That's where the greatness comes from. You gotta bump your head enough times to where you get it, all right? But if you never bump your head, then you never get it, and you never unlock your talents or whatever. Okay, let's do a quick check. So 18 plus 3 is indeed 21. 27 minus 4 is indeed 23, right? So when we plug these into the original, they work. Okay. So I think the textbook chose to eliminate the y as well, and I think they chose the same steps that we got. X equals 9, and then y equals 1. Okay, and then they also check to make sure that 9, 1 works in both equations. Okay. All right, so here in this example, we're going to revisit substitution, but now we're going to use a technique that's called linearizing substitution, right? I think that's how you say that. That's about the best I can do. It's still the substitution technique, but there's a caveat. Let me see. So here, we're going to let u be 1 over x, and we're going to let v be 1 over y. So we're replacing 1 over x with u, we're replacing 1 over y with v, okay? So then that transforms the system. Now, I need to add a page. Hopefully it doesn't throw another tantrum, because it's good for that. Add a page. Yay, I'm so proud of you. Oh, we're selling seamless? I didn't even realize. Okay. All right. So now when we make these substitutions, we're going to transform this into something that's much easier to work with. So then we're going to have 2u plus 5y equals -5, 3u minus, whoops, that's a v, right? 5v, and then minus 2v equals -17. So we transformed that nonlinear, we linearized it, right? We transformed it to from nonlinear to linear to make it easier to work with. Okay. Okay, so we can use either technique. I feel like elimination is going to be the easier way to go here. And I think I eliminated u with my earlier class. So with you all, I'm going to eliminate the v. So if I'm eliminating v, least common multiple between 5 and 2 is going to be 10. So I'm going to multiply this first row by 2, everything by 2. And the second row, I'm going to multiply everything by 5. Okay. So then when we do this, we get 4u plus 10v equals a -10. We get 15u minus 10v. See, 50 plus 35 is 85. Okay. So now when we add the two equations together, a number plus its opposite adds to 0. Okay. Equal sign comes down. We get 19u there. We get -95. Let's see. 5. Hey Siri, what's 95 divided by 19?
95 divided by 19 is 5.
Okay. So then let's take this and find V. I feel like equation 1 might be a little bit more simple than equation 2 to work with. So we're going to say 2 times -5 plus 5V equals -5. Okay. That's going to be a -10. So then we're going to get, here, let's just write it out. -10 plus 5V equals -5. Add 10 on both sides. We get 5. So then V equals 1. Okay. Now we solved for U and V, but now we need to go back and plug them in. I think we said U was 1 over X. So if U is 1 over X and Y, and V is 1 over Y, so then -5 equals 1 over X. If you cross multiply, X equals a -1 over 5, okay? And then for V, 1 equals 1 over Y. So when you cross multiply, Y equals 1, okay? So then our claim is that the solution to the system is a -1 by 5, 1. Paste. Okay, let's copy. Okay. I'm just going to piggyback off my prepared notes because we're essentially out of time. All right. So I think they did the same thing. It's basically U substitution is what I call it. They replace 1 over X by U. And you see X equals a -1 by 5 and Y equals 1. Okay. And you can verify. Okay, we are essentially out of time. Did you guys have any questions for me? Have any questions?
So do you know exactly how long this final exam may be?
Similar to exams 1, 2, and 3, you have 5 days to work on it, unlimited attempts. It's just, a little bit of exam 1. It's just a little bit of everything.
So it's gonna be on Pearson's.
Yeah, it's still on Pearson.
Okay, cool.
Yep. All right, any other questions? Oh shoot. No, I don't think they wrote anything. Okay. All right, so when this bar finishes loading, you'll get a copy of everything that you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.